Welcome, IB students. We are continuing our study of geometry and trigonometry, which is topic 3. Prior to this lesson, you most likely just watched 3.1's first video, which was on geometry, specifically midpoint and distance formula, and also calculating the volume of a pyramid and the angle between a face of the pyramid and the base. So this is our follow-up video on the reverse side of your notes, where we are going to look at surface area and volume, specifically of a combined solid. So I want to flip back to the front side, and this is a little snippet of what is included in the IB syllabus guide. And so we are expected to know the volume and surface area of 3D solids, including right pyramid, right cone, sphere, hemisphere, and combinations of these solids. And they very specifically mention over here, you should be able to identify relevant right-angled triangles in 3D objects and use them to find unknown lengths and angles. Okay, so I'm going to come back over. Let's look at our story. It says a container shaped like a right circular cylinder has a diameter of 12 centimeters and a height of 15 centimeters filled with ice cream. The ice cream is to be filled into cones of height 12 centimeters and diameter 6 centimeters, having a hemispherical shape on the top. Find the number of complete cones that can be filled with ice cream. All right, so you basically have a tub of, let's say, Ben & Jerry's ice cream. If all of your cones are going to have the exact same dimensions, how many complete cones can you create? So we want to start by finding the volume of the sphere, of the cylinder, the volume of the cone plus the spherical section on top, and then we can divide the total ice cream by how much an individual cone takes to find out how many cones we filled altogether. So the first thing I need to do is I need to know my volume of a cylinder formula. And so if you look at your formula packet, I'm going to start by reviewing what's available in 3.1, which is volume of a right pyramid, right cone, curved surface of a cone, sphere, and surface area of a sphere. What you'll notice, there is no volume of a cylinder. That just means that it is previous knowledge. That means it is located at the beginning of your formula packet in the prior learning section. And so here I find my volume of a cylinder, and it is pi r squared h. Pi r squared is the area of your base, so it's the area of your base times h. So I'm going to go ahead and start by writing that formula. Volume equals pi r squared h. And let's drop in what we know. So we know our diameter is 12. Therefore, our radius is 6. So we have 6 squared, and then we have our height, which is 15. So I'm going to leave my answers in exact form. So that gives me 540 pi. And you can approximate that if you want. I'm going to leave it in exact form for right now. Now I want to find the volume of this figure, and this is a combination of two figures. So the bottom is the volume of the cone, and then it's the volume of a sphere, but it's only half of the sphere. So I'm going to say half of the volume of a sphere. And I'm going to go grab those two formulas. So I'm looking for, hold on a second, we're going to go back to section 3.1. We have volume of a right cone is 1/3 pi r squared h, and we have volume of a sphere is 4/3 pi r cubed. So we're going to include those here. So volume of a cone is the 1/3 pi r squared h plus half of the volume of a sphere, which is 4/3 pi r cubed. And we're going to drop in what we know. So again, they're telling me that my diameter is 6, which means my radius is 3, and they gave me my height of 12. So I have 1/3 times pi times my radius is 3 squared times my height, which is 12, plus, I'm going to go ahead and combine these in the front. So that's 4/6 or 2/3 pi times my radius, which is 3 cubed. And I'm also going to clean this up as much as possible. So 3 squared is 9. 1/3 of 9 is 3. Times 12 is 36 pi. 3 cubed is 27. 3 goes into 27 9 times. 9 times 2 is 18. So we have 18 pi. And when you add these two together, we get 54 pi. Okay, so, oh, sorry, we're kind of cockeyed there. All right, so now we are finding how many cones can be created with the volume of the cylinder. So I'm going to take the volume of the cylinder and divide it by the total volume of the ice cream cone. I'm going to put cone here, but we're going to know that it's really the cone plus the hemisphere. So that would be 540 pi divided by 54 pi. Our pi's cancel. 54 goes into that 10 times. So that worked out nice and pretty. You have a nice full 10 cones. I do want to mention, just as a hypothetical, what if you had received 10.3 cones as your answer? You have to be very careful with IB wording. The wording in the problem says find the number of complete cones. And this would have only created 10 complete cones. So this would be rounded down to 10. Even if this had been 10.8 cones, where your instinct is probably to round up, you only have 10 complete cones. So you would still round down to 10. So that obviously doesn't apply on this problem because we got a nice pretty number. This is my final answer, 10 cones. This is just a little hypothetical situation. Okay, we've got one more follow-up question. Example number 4. What is the surface area of the waffle portion of the cone on the previous problem? So we are imagining the curved part of the cone itself is the waffle part. So that is surface area of the curved section of a cone. So we have that formula given to us. We've got area of the curved surface of a cone. It's pi r times, and this little kind of slanted L is your slant height. So pi r times your slant height. So surface area equals pi r times my slant height. And when you are talking about this cone, I'm actually going to draw the cone down here. It's the same cone that's up above. You know that you have a radius of 3, and they gave you this height of 12. But really, what you're being asked to use is the slant height. The slant height is this side length over here. And so I know that the radius and the height create a 90-degree angle. So this actually constructs a right triangle. And I want to find that third side of a right triangle, which means we can use our Pythagorean theorem. A squared plus b squared equals c squared. So 3 squared plus 12 squared is my height, equals my c squared, which is going to be my slant. So 9 plus 144, which is going to be 153. And we'll take this square root. And I'll just leave this as square root of 153 right now. We do get plus or minus, but we only are concerned with the positive version since this is a real life distance. All right, let's drop in what we know. So my radius is 3. My slant height is square root of 153. And if you wanted to leave that like this, 3 pi square root of 153, that's fine. If you wanted to actually approximate that, we would get, rounding to 3 significant figures, I would actually get 117. Let's throw a unit on there. So we are working with centimeters, so this is an area, so that would be centimeters squared. So that's the answer to the first part of the question. Second part of the question says, what would the entire surface area of the cone be, including the hemispherical ice cream on top? So we've already got the waffle part of the cone. I would want to add that. So this is my waffle part, right? I would want to add to that the area of this hemisphere on top. So what I want to do is find the area of a sphere and work with half of that. So going back to our formula packet, surface area of a sphere is pi r squared. So I'm going to take half of 4 pi r squared. So half of that surface area. And my radius is 3. So half of 4 is 2. Oh, I'm so sorry. That 2 does not belong outside there. That belongs in there. There we go. So half of 4 is 2 times 9 is 18. So we have 18 pi for the area of the hemisphere. And they want the total area, so we're actually going to combine these two together. So I'm going to take the area of the cone, the curved part of the cone, plus the area of the hemisphere. And so that would be my 116.578 plus my 18 pi. And even when I grab that 116.578, I am using the exact answer on my calculator. I'm not going to use a rounded number. And that gives me a total area of 173, and that is centimeters squared. Okay, so now you've seen several examples of volume and surface area. I wish you all the best. That concludes our section in geometry.